are you doing today?
I'm good. How are you?
I'm good. So we're going to talk about a few things. So first I just want to ask you, can you tell me what a mutation is in DNA?
A mutation is...
That's okay,
Give me
take
a
your
second.
time.
It'll come to me in a second.
Take your time.
I need examples of it. Just like
Go ahead, that'll work.
like splicing or like was it base deletion or it's something in the genetic code that isn't supposed to be there or it has been removed.
That's a really good way to explain it. I like that. So my next question is, can you remember the different types? And you kind of were getting on that base deletion.
Was it like 3 or 4? Actually, I know there's insertion, deletion. There's one where it's like it translates. It doesn't make that big of a difference in the actual translation of the code.
Right.
And then there's one that changes it to a different protein.
Okay. Yeah, but it sounds good. Very good. Okay. So, do you think mutations in DNA are always bad?
No, some can be beneficial.
Okay. Why do you think so?
They can have an advantage, like fitness-wise, with the population or an organism. For example, we have HIV resistance, which could be like a beneficial mutation.
That's cool. Like, what do you mean when you said fitness? Like,
improves the organism's ability to survive or adapt in whatever environment they're in.
Cool. I like the way you think. Okay. So, how do mutations occur? Like, are they planned or are they random?
They're not planned. They're usually random. Sometimes DNA polymerase can make a mistake. That's pretty rare usually. But they also have like with recombination. Sometimes they'll have mistakes there.
So what's another way we can describe that? Like another word for random? Can you think of any? It's okay. No worries. I was just wondering.
Is it like scientific terminology?
Kind of, but this word like is also used in other things besides science. Don't worry about it. It's okay. I'll tell you later.
Okay.
So you said they're random and everything. So when can they be bad or not beneficial? So my question is not beneficial the same thing as harmful?
It's not beneficial the same thing as harmful. I don't think so, because if it's not beneficial, it doesn't have to be harmful. It can still be like a neutral mutation.
Yeah, that's actually, yeah. No, don't worry. This is not about being right or wrong. I just want to, see how your brain works. And right now it's working the same way as mine is. So can you think of an example when a mutation cannot be beneficial but then also not harmful? Like you said, neutral. Can you think of an example?
So there was that one mutation. So if you have, what was it? It gives you like the same base, even though it's just like one layer that's off. I guess that could be a neutral one.
Yeah.
It doesn't really make an effect.
When you say
or
effect.
It doesn't like have like a physical effect.
Okay. Is there another like word you can think of like physical effect that is used to describe what the DNA expresses? The other day I had a brain fart too, and I was like, "What is that word?" I'm like, "Oh yeah." It's okay if you can't think of it.
It's like expressed, like.
So like the word that scientists use to say how DNA is like, for instance, like the difference between like a genotype and then a this.
Like a phenotype.
Yeah. So like, would you say so if it's a neutral mutation, how would that look phenotypically? Would it be different? Can it be different, you think, or can it not? What do you think?
It can, and also it can and it can't.
Right. That's. I'm sorry, I got a phone call and it interrupted, but we're gonna continue. So sorry. So you said a mutation that is neutral hair color. That's one way of like showing that a mutation neutral phenotypically. And you also said that if a mutation is neutral, it doesn't necessarily have to show phenotypically, right?
Yeah.
I think that's what you said.
Yeah.
Yeah. So cool. Okay. So the hair color, why would that not be harmful?
Well, it depends on where that organism's living. For example, if there's a predator that eats humans and they see blonde hair and it's easier for them to see, then that would technically be a deleterious mutation.
That's a good point.
But it could be neutral, at least for us, since we
Mhm.
don't have that problem.
Right. That's a really good point. Okay. So what about a mutation that can be harmful? Can you think of an example?
Bacteria that has resistance
Ooh, that's a good one. I didn't think about it that way. Why would that be
Viruses.
considered harmful?
We can get infected and stuff, and our antibiotics and all that wouldn't work.
Yeah. Like so, that mutation in the bacteria. So you say that antibiotics wouldn't work. Why wouldn't they work exactly?
They would have beneficial mutation. What was the question? I'm sorry.
No, it's okay. So you said, I asked an example for a harmful mutation, and you said the bacteria.
Harmful,
So
okay,
it would be beneficial to them, but then harmful for the who?
or infects.
Right.
But that's not really a mutation, that would just be an effect. Let's see, a beneficial or a deleterious mutation.
I like that word, deleterious mutation. What do you mean by that?
It's like bad mutation.
Okay.
It'll come to me in a second, but I think of something.
So what about,
Like sickle cell.
okay,
I don't know if that's.
so sickle cell. What's sickle cell?
Before I say the wrong word.
No.
There's something about like the red blood cells and they're just like misshapen or something like that.
Okay.
I don't actually remember entirely.
So how can that be harmful?
They're not working like they're supposed to.
So what would that mean for the organism if the blood cell is not working?
Organisms at a disadvantage in compared to other organisms within their population.
Yeah. Okay, so a mutation. Does that just affect the individual? Like once it affects that person, then it goes away, or what?
Oh, it gets passed down.
It gets passed down. What's another word for that we can use? No, it's okay. Passed down. We'll use passed down. So how can they be passed down or inherited?
Inherited. That was what we were looking for. Okay. Like recombination, I guess just.
So if hold on, let's go back. Oh no, never mind. We were talking about harmful. That phone call really messed me up. Okay, so if it's harmful, can you tell me what inherited means? I'm sorry.
Being passed down from parent to offspring.
Beautiful. So if this mutation is not beneficial, and even some that's harmful, why and how can it still be inherited?
It's kind of randomized. It's not like your gene picks and chooses what gets to be passed down. It's just kind of like.
So if it's random, right? And say so it gets passed down to the offspring, and then it keeps getting like inherited because it's not affecting the fitness that you said so much. Like, why do you think that's the case?
their genes.
So what do you think makes it possible for those things to keep getting passed down, and it's not like it's a harmful ish mutation, but they're still able to carry that mutation to their offspring? Can you think of something why does that happen? Do you think they always know if they have that mutation in their genetic code?
No, they could have that mutation and not know.
Right. That's if they don't know they have it,
it just gets passed down.
and
Unless it actually affects their being and they pass.
yeah. Of course, some you think that some deleterious. I'm gonna use your word, deleterious mutations. Do they always get passed down?
No, not always.
Right.
They can.
Because if there's some deleterious mutations, will they be so deleterious to where they'll kill the organism, so to speak, sometimes? Okay, so let's draw a Punnett square real quick for that. Okay, so let's see. I don't think.
We used to have markers.
So we're talking about a mutation. So we were talking about sickle cell, but can we think of another example of a mutation that, let's say, okay, I'll let you draw. So let's say mom is not affected, but she's a carrier. So first, can you tell me what being a carrier means?
They have the gene. They carry it, but it's not shown. It's not
So why isn't it
typically
shown? Speaking on DNA and gene chromosome level, what does being a carrier mean in that sense? Do you think?
you have that. Are you talking about mutations?
Mm-hmm.
They have it, but it's not turned on. Is that so you can see it?
Well, yeah, actually, I didn't think about that. That could be a way. So carrier, what just that word in general? What do you think what does that mean to you?
They carry something.
Right. So they carry something. If something, let's talk about alleles now. So
Alleles. That was the word that I was thinking of.
yeah, no problem. So if she's a carrier, what would that mean on the allele level?
So if this person's a carrier,
But she's not affected. What does that mean? Both
if you need to be affected, and this is what you need to be affected, this person would be a carrier.
Right. So what can you tell me about this? What is that? What do we call that?
What do you mean?
If these two, so they're both lowercase. What do we call that?
The recessive.
Recessive, yes. And what else can we call because they're the same?
Homogeneous.
Homozygous. Yes. Sorry, I didn't mean to correct
I'm
you. You were there. You said homo, and I'm that means the same. So you were there. So then,
It's been a long day.
So then, what does this mean? What do we usually call
It's
that?
dominant.
And then what about when they're
Heterozygous.
together? Heterozygous. So, what could you say about the word carrier in terms of genetics and heterozygous?
In terms of
Those words and what they're meaning, what could you say about them and their relation? Do they relate? Do you think they relate to each other, or do you think
if you're a carrier, you would be heterozygous.
Yeah, that's it. Yeah, perfect. I like that answer. Okay, so if mom's a carrier, would she automatically know that?
No.
How would she find that out? How could she find
Get
that out?
tested.
And what else? That's a good one. Say
If
we're
you,
back in the
if you have kids and stuff like that, if one of your kids shows evidence of whatever issue that you're looking at, it's likely that the mom is a carrier as well.
Oh, that's beautiful. I like that. So can we use the example of color blindness?
Okay, yeah.
So that mutation. So let's draw a Punnett square first. It's a beautiful Punnett square. So we'll put mom on top and then dad on the side. So do you remember anything about the nature of color blindness?
No.
That's okay. No worries. So color blindness, we could say, is sex-linked recessive. Can you tell me a little bit about that?
X and Y.
X and Y. Okay. So,
Mom is
so what is that? What is mom? Why does she have two X's?
she just has
Does that represent? What does the X represent?
sex. What's the word? It'll come to me in a second.
No problem. It's another way to say DNA clumped into a thing.
Yeah.
I know. It's okay.
It's there. It's yes, chromosome.
Chromosome. Yeah, you said it, not me. Okay. So mom, she's female. She has two X's. And then dad, what did you write there? X and Y. Okay, so sex-linked recessive. When you see the word sex-linked, what does that tell you?
It's carried on these chromosomes.
What are these chromosomes called? You just said it.
Sex-linked.
So what kind of chromosomes would these be?
The X's?
Would these be called the sex chromosomes? Is that what they're called? Actually, I might be wrong. No, yeah, I think so. So the X and Y are those? Would you say those are called the sex chromosomes?
Sure. Yeah.
Yeah. I like that. Cool. Whatever you think. I shouldn't have said that. That's fine. Okay. So I see. Mom has two X's. Dad has X and Y. So now that we got the sex linked, and you said that mutation must be on one of these
Is the
chromosomes.
chromosome carried on the X? Oh, sorry, chromosome. The colorblindness.
If it's sex linked recessive and mom's a carrier.
Oh, mom is a carrier, so then yes.
So with that, yeah.
So then colorblindness, the dad's also. Do you need to have both to be colorblind?
Well, you tell me.
This is a carrier thing, yeah.
So if mom is a carrier and dad, what does that say? So dad has how many X chromosomes?
One.
So if his only X chromosome has the mutation, what would that say about dad?
He is colorblind.
Right. Cool.
So
Yeah, you can complete the Punnett square.
That's a colorblind person, that's a colorblind person, that's a carrier, and that person's common.
Perfect. So what is this? You just told me that. What does it say about the progeny? So if what does one square kind of represent about the percentage of the progeny?
It's like 25% of the progeny would be one of these.
Now 25%, is that like, would you say exactly 25% will have it, or is that more of like a
Not exactly.
guess, or what's the scientific name for a guess? A prediction. Sorry, I was like, I'm sorry. So that'd be more of a prediction or like an exact number. What do you think?
It doesn't have to be an exact number, it's more like a guess, and like if you had this many kids in general, this is how many, what percentage of them would likely have
Cool.
one of these.
So, so we all talked about that. Cool. Now let's talk real quick about beneficial mutations in general. When would a mutation be beneficial? Can you give a specific example?
Lactose tolerance?
Lactose tolerance?
Yeah.
Like instead of intolerance?
Yeah.
Yeah. That's a cool example. Why would that be beneficial?
You can continue to get the nutrients that you need from that source without having implications.
Yeah, exactly. So how and why do these beneficial mutations stay around?
They get passed down.
Why do they get passed down? But this is kind of, I'm like,
you can
don't
say that
overthink these questions. Sometimes I'm asking you more of like, emphasizing. So why do you think the beneficial mutations get passed down?
you can say like these people may have a higher fitness and within their population, so they're more likely to have those genes passed down.
Nice. So can you tell me like a special process that scientists use to describe that, like beneficial mutations being passed down, and like
The processes.
no problem. So like another way to say that is, so we have a change, and that beneficial change,
Like
evolution, yeah. What specifically causes or contributes to evolution?
Mutations.
Yes, and how would mutations like can you tell me like what kind of the process in your mind goes from how it goes from mutation to evolution?
It kind of like weeds out the people who have deleterious mutations and promotes ones that have beneficial ones, so that it gets passed down.
What did you can't think of anything to call that, because that's a specific everything. That was a beautiful description of this one phrase.
It's a term, isn't it?
Kind of. It's okay if you can't think of it. So we call this natural selection.
Oh,
Can you think of another way to say like this cool, cute-ish phrase of natural selection?
What do you mean?
Like another like way to say natural selection to like say first graders. Kind of, but their adaptation. Never mind. So we can say instead of dying off, they are doing what?
Evolving.
And what else? So what would be the opposite of dying?
Thriving.
Thriving, or what else? What are we trying to do in this last few weeks of this program?
Presenting.
We can say we're surviving.
Okay.
So
So you're saying like it increases their chances for survival.
of the fittest. No. So how can natural selection lead to evolution over time? We're almost out of time.
Selection leads to evolution.
You kind of wear it.
Selecting them.
Yeah, actually you did say that already. I'm sorry. So do you think evolution happens quickly?
It's a gradual process.
It's a gradual. What do you mean by that?
It takes a few generations.
Can you tell me what a generation is?
Parent to child to parent to child.
Right. So, cool. So, we talked about that question. Okay, and I think we are out of time. Yes, so briefly, can you just kind of, in your own mind, from what we talked about in the beginning, can you kind of, if you want to draw it, you can, how it can go from mutation to evolution?
So, mutations are random things that affect your genes and can be beneficial, neutral, deleterious. If they're deleterious and can affect the fitness of the population or individual, it is likely to be removed over time, as in like they'll die. And then if it's beneficial, those are likely to be passed down. And I guess through the process of eliminating deleterious or sometimes neutral mutations, you can, or the organism can evolve over time.
What, is the organism evolving, or?
Well, not the individual organism, but like the type of whatever.
The species. Or the population. Or,
Yeah.
Very good. You are so smart. And real quick, why do you think evolution is useful?
for us.
For anything.
It shows us that, well, it's like kind of like when developing antibiotics and stuff like that, where like you need to be aware of it so that you can continue to create antibiotics that would work for the populations of like bacteria that are resolving if at a quicker rate.
Okay, very good. I like
Find
the
a way to protect yourself.
Find a way to protect yourself. I love the way your brain works. Okay, thank you so much. This concludes our interview. I thank you so much.